All right. For number 12, it actually says use geometry software to find each length. We are actually going to do this by hand. So I'm going to move this over to a separate piece of paper just so I have room. A asked us to find the length of CR. B asked me to find the length of RN. C asked me to find the length of AR. D asked me to find the length of RE. E asked me to find the length of GR. And F asked me to find the length of RH. Now, before I get this done, we're talking about finding the length of a distance. So we're going to say distance equals x1 minus x2 squared plus y1 minus y2 squared. This is the formula for distance. I'm going to give you some important points that we came across along the way. A is located at 0, 0. C is located at 12, 24. G is located at 36, 0. Then we have H is located at 6, 12. E is located at 24, 12. N is located at 18, 0. And our R, which is our concurrency or our centroid, is located at 16, 8. For this part of the lesson, we're going to do questions 12, 13, and 14. 12 asked us to find the length of all these measures. Then 13 asked us to compare the lengths of the collinear segments and what relationships do we notice between the distance from the vertex to the centroid and the distance from the centroid to the midpoint. 14 asked us, the relationship you noticed in item 13 can be stated as a theorem. Complete the centroid measure theorem. And it asks you to fill in the blank. And then it moves on to a different section. So let's go ahead and take a look at 12, 13, and 14. And for this set of questions, I'm going to give you another 15 minutes. First, the longest part is going to take is to find the distance of each one of these pieces by hand. All right, go ahead and pause your video. Take your 15 minutes to find your distances. First, found the distance of all of these pieces. I noticed that the following. CR was approximately 16.49. RN was approximately 8.25. AR was approximately 17.89. RE was approximately 8.94. We had GR was approximately 21.54. And RH was approximately 10.77. I also did the simplification of leaving it in the radical form. So this was 4 square root of 17, while this was 2 square root of 17. This was 8 square root of 5. This was 4 square root of 5. This is 4 square root of 29. This is 2 square root of 29. So question 13 asks us, what do we notice about the distance from the vertex to the centroid and then the centroid to the midpoint? Well, these are my distances to the centroid. So this is from vertex to centroid in this column. And these over here are centroid to midpoints. And if you look, this is half of it. This is half of it. This is half of it. So if we were going the other way, this is twice the size. So whenever I said this, I said the distance from the vertex to the centroid is twice the distance from the centroid to the midpoint. And that leads into this theorem of the centroid measure theorem. The centroid of a triangle divides each median into two parts so that the distance from the vertex to the centroid is twice the distance from the centroid to the midpoint of the opposite side. The centroid is also the center of mass or balance point of any triangle. On to your debriefing question.